Hi guys, welcome to my channel. Hope you're doing good. So today we are going to look at the sliding window coding pattern. Let's try to understand this pattern in this video and solve programs later on. So please keep watching. So let's start with an example. Imagine that you're given an array of positive integers and you're asked to find the maximum sum of contiguous subarrays of size k, and in our case I have taken case value as 5. Okay, so let's forget about the optimizations and let's see how we could approach this problem. So I need to find the sum of every subarrays of size k, right, and I need to find which subarray has the maximum sum. So that's what I get in my mind when I see this problem at first. So how we could do that is I would start from the first integer and I would keep calculating the sum, and it stops here because there are 5 integers here, and our subarray size should be 5, right? So it stops here, and the sum would be we would be calculating the sum for every iteration, and we would get the sum as 19. So in the next iteration we would start from the second integer and go up to the fifth integer, so that we have 5 elements in our subarray, and this would give us a sum of 16. Now we'll check if the maximum sum is greater than the one we calculated now. No, so maximum sum remains 19. And then we'll start from the third integer and we'll go up to the fifth integer, and we'll be calculating the sum for this, and it would give us 13, and we'll check if this 13 is greater than 19, the maximum sum that we calculated already, and no, it's not, so maximum sum remains 19. And we can't go to the next iteration because we won't get enough elements in our subarray, because when you start from 3 there are just 4 integers here, so we'll stop our iteration here and we'll return maximum sum as 19. So now we have an idea of how to approach this problem without thinking of any optimizations. We just approach this problem using the brute force approach, and let's see how we could do this by program, and we'll see what time complexity we get out of it, and this would help us in understanding how sliding window could be useful. As you see, we need a for loop to keep track of the number of iterations, and we also need a for loop to keep calculating the sum of every subarray, right? So we'll be having 2 for loops here in this method. Okay, so let's see how we'll do it by program. So here is a program to solve a problem using brute force approach. Like I mentioned in the discussion, we'll be having 2 for loops here. One for loop is to track the number of subarrays, okay, and the other for loop is to calculate the sum of every subarray. And in our case there are 7 integers and we can only go up to the third subarray. We can just have 3 subarrays, because if we go to number 3, the fourth integer in our array, then we won't be having sufficient elements to satisfy the condition that our subarray can only have 5 elements, right? So we'll be stopping up to 1, and that's why we have array.length minus k in our iteration condition. So the second for loop calculates the sum of this current subarray. So that's what we are doing here. We keep adding every integers in the subarray, and we also keep updating the maximum sum. That is, if at all the currently calculated sum is greater than the maximum sum, then the value will be replaced there in the maximum sum variable, and that's what we are returning out of our function. This is how we are going to approach this problem if we are going to use a brute force approach and not do any optimizations. Here, as we can see, the time complexity would be big O of n into k, because for every element in the array we are calculating the sum of next k elements. So the time complexity would be big O of n into k. So let's see how we could improve this and see how sliding window could be useful for us in this. Okay, so we saw how we could approach this problem using a brute force approach. We also saw the program of how we could do it, and we saw that we had to use 2 for loops, and the time complexity was big of n into k. Now it's time to think about the optimizations and see where we could improve this problem and reduce the time complexity. Okay, did you realize something here that we are calculating the sum of the subarrays every time and not making use of any previously calculated values, right? So what I'm coming to say is, in the first subarray we had the sum calculated as 19, and in the second subarray we again calculated the sum of these integers 4, 1, 3, 6, 2, and we got the sum as 16. However, 4, 1, 3, 6, these integers, for the sum of these integers were calculated in the first subarray sum calculation as well as second subarray sum calculation, right? So we could have optimized it in such a way that we use the previously calculated values, and this is where sliding window comes into picture. So sliding window is going to help us reuse the previously calculated values so that we don't keep calculating the sum again and again. Okay, so that's how we are going to optimize this problem. We know that we need to make use of the previously calculated values, and we also know that the calculation of sum for these integers, that is 4, 1, 3, 6, was repeated in the first subarray sum calculation as well as second subarray sum calculation, right? So what happened in the second subarray sum calculation? What happened in the second subarray? 5 has gone out and 2 has come in as a new element, right? So this is what we are going to do. We are going to subtract 5 from our sum, 19 minus 5, and we are going to add to the new element that is coming into our subarray. So the old element that is going out of the subarray is going to be subtracted, and the new element that is coming into a subarray is going to be added. So this is what we are going to do with sliding window. So let's see in detail how we are going to do this. I'm going to have 2 pointers here. One is window start. So one is going to be window start, and the other is going to be window end. We know that k is equal to 5 in our case, and window start and window end is going to be pointing to the same first index of the array, that is 0. Okay, we are going to keep moving over the array. We are going to keep iterating over the array using window end, and so we should make sure that whenever that window end is greater or equal to k minus 1, that is 4, then it means we have reached the maximum number of elements in a subarray, and we have to slide the window like we discussed. Okay, so let's see how we could do that. We have something called sum, which will be initialized to 0, and we are also going to maintain maximum sum. Okay, so in the first case sum is going to be 0 plus array of window end. Window end is 0, so it's going to be 0 plus 5, which is going to give us 5. Okay, and then we are going to increment window end. Okay, so next it will be, sum will be 5 plus 4, which is 9, and then we are going to increment, and now the sum is going to be 9 plus 1, which is 10, and we are going to increment window end. Okay, sum is going to be 10 plus 3, which is 13, and now we are going to increment window end pointer again. Okay, so now the sum would be 13 plus 6, which is 19, right? So now you keep checking whether window end, whether this condition is satisfied after every sum calculation, and now as you can see, window end is pointing to 4, right, fourth index, and it has matched this condition, which means there are 5 elements in a subarray, right? There are 5 elements here, means one subarray calculation is done. So what we are going to do, we need to remove this element from our subarray calculation, and we need to slide our window, right? So that's what we do at the end of this. So we are going to subtract array of window start, which is going to be 19 minus 5, which is going to give us 14. And then we are going to slide the window. So window start will point to the first element now. Okay, yeah. And now what we are going to do is, we are also the window end would have got incremented, so it would be pointing here. Okay, so window sum would be 14 plus 2, which is going to give us 16. Okay, and again we know that window end is pointing to 5, which satisfies this condition that we have. So again it means we need to slide our window. So this number is going out, right? So it's going to be 16 minus 4, which is going to be 12. Okay, and then you're going to increment window end. Now window end is pointing here. So and you would have also slided the window, so window start would be pointing to index 2. Yeah, and now sum would be 12 plus 1, which is 13. Here, this one, right? Remember that for every iteration you would also be updating the maximum sum value, which would be 19 as of now, because it would have got updated to 19 here. It wouldn't have changed, so it would have remained 19. So this is how you would keep going using the sliding window approach. So now we are going to go to the program, and before that I want to make sure that this is clear, so let me explain it to you in short again. So we are going to have two pointers here, window start and window end, and window end is what is going to go over your array and calculate the sum for you, and window start is going to represent the start of the window. So we should also be checking that our subarray size doesn't exceed 5, so that's why we kept checking this condition, whether a window end is greater than or equal to 4 in every iteration, and whenever it satisfied this condition, it means that our subarray size is 5, and what we did was we subtracted the value of window start from the sum calculated, and we slided over the window start. Okay, so now let's see how we could code and use a sliding window pattern, and I'm sure it's going to be easier because we know what we have to do. Like we discussed, we are going to have a pointer called window start, and it's going to point to the first element of the array, and we are also going to keep track of the sum, and it's going to be initialized as 0, and we are going to keep checking the maximum sum, and that's what we are going to return, and it's going to be the minimum value, because we have to whenever a maximum sum is there, we have to replace that, and this is what we are going to return, right? Maximum sum is what our program wants. So there's going to be a for loop, and we are going to have the other pointer, which is window end, and that's going to point to the first element in the starting, and window end should be lesser than array dot length, and we'll keep incrementing that. That's what is going to go over the array and calculate the sum, right? And we are going to keep calculating the sum. So like we just discussed, whenever the subarray size limit has reached, we are going to slide our window, and before that we are going to subtract the starting value of the window, so from our sum. So that's what I'm going to do now. So whenever window end is greater or equal to k minus 1, in that case what I'm going to do is I'm going to subtract the starting value wherever a window is pointing to, and I'm going to slide my window. So window start is incremented, but before all this we should update our sum, maximum sum, right? For every subarray we should keep updating a maximum sum. So maximum sum would be maximum of the sum calculated as well as maximum sum. Okay, so that's it, that's the problem, and let's run it. Maximum sum of subarrays of size k is 19, so that's what we wanted. So the time complexity of this program is going to be big of n, because we just have one for loop that's going over the length of the array. So we have come down from big of n into k, which was for the brute force approach, to big of n using our sliding window approach. So this is a very useful pattern. Now we saw the fixed size k, right? Our window size was fixed in this case, but there are also other programs which will have dynamic window sizing, and there are also many other programs that makes use of the sliding window approach, which is what we are going to see in my other videos. Thank you for watching. Hope this video was helpful. I'll come up with different programs that uses this sliding window pattern, and also please let me know in the comment section what other coding patterns that you want me to explain, and also other programs that you want me to code, so I can do it for you. Meet you again soon. Thank you.